These are video notes on calculating interest. To start, we're going to get a quick definition for what interest is. There are two ways that you can either earn interest or be charged interest. Interest is going to either be money earned on a savings account or an investment, or it could be money that you pay for borrowing money. So if you borrow money from an older sibling and they charge you $6 instead of 5 when you pay it back, you would have been charged $1 interest. With interest, there's a formula that you will always be using. Our value for interest is going to be equal to the product of these three things multiplied together. So you're going to multiply the principal, and the principal is going to be your starting amount. So next to where you have that in your equation, we're also going to write that that's your starting amount. If you have a bank account, it's how much money you're putting in the bank. If it's a loan, it's the original amount of the loan. You're going to multiply that by your interest rate, which is going to be represented as a percent. You are always going to be writing your percents as a decimal when you put these into the equation. And then the third thing that we're going to multiply by is the number of years, which is your time. Be aware that time will always be represented in years, so even if you have 6 months, you would represent that as 1/2 of a year when you plug it into the equation. All right, let's take a look at how you would actually use this equation. So it says you put $500 in a savings account, you earn 3% interest per year, and we're going to start by finding how much interest you earn after 3 years. For every single interest problem, you're going to start with your formula. So we're going to use I to represent interest, P to represent principal, R for rate, and T for time. So it's just using this equation right here, but plugging in those letters. Okay, once we have our equation, we're going to plug in the values we know. It says that you put $500 in your savings account, so that's going to be substituted in place of the principal. It tells you that your interest rate is 3%. That's going to be your rate, but we need to enter that as a decimal. 3% would be equal to 3/100. So we're just going to be moving this decimal place to the left 2 places to get 3/100. And then time is 3 years. So we're going to substitute a 3 in place of time. With interest problems, you're going to have 3 of the 4 variables, and so you're going to plug them into your equation, and then we'll fill in the rest with our equal signs and our multiplication signs. Okay, from here, I just need to multiply these 3 numbers together. I can multiply those in any order I want using the commutative property. So I'm going to go ahead and multiply 500 times 3 first, just since those are my 2 whole numbers. And then once I get my value of 1500, I can multiply that by 3%. And so that's going to give me an interest amount of $45. And since we're looking for amount of interest, we're going to put the $ on for our units. Okay, for part B, it says what is the balance after 3 years? I started with $500 and I made $45 in interest. So my total balance is just going to be $545. Okay, next we're going to look at how to calculate the rate. So it says you put $1,000 in an account, you earn $100 interest, and it takes 4 years. So as we did before, we're going to start with our formula. Interest equals principal times rate times time. Okay, it says you put $1,000 into your account. That's your starting amount. That's your principal. So I'll plug that in underneath P. It tells us that we earn $100 in interest, so that's going to go underneath the I. And it also tells us that it takes 4 years. So I'm going to plug that in underneath T for time. And now I'm just going to bring down everything I haven't used. So I have an equal sign, I have times a rate, and times 4. It asked for the rate, so it would make sense that I'm solving for R. Okay, we'll start by multiplying 1,000 times 4, which is 4,000. And then to solve this equation, we're going to divide by 4,000 on each side. So now I'll set up my division box for 100 divided by 4,000. And since 4,000 is larger, I'm going to go ahead and just add in a decimal point with a couple zeros since I know I'll need them. Okay, so 4,000 does not go into any of the numbers up until 100. It does not go into 1,000, but 4,000 will go into 10,000 twice. So we'll subtract, and then we'll need one more 0, and 4,000 goes into 20,000 exactly 5 times. So I get a value of 25 thousandths. And we know that interest rates need to be represented as a percentage, so I'm going to convert 25 thousandths into a percentage by just multiplying by 100. That's going to slide my decimal point over 2 places. So my final answer is 2.5%. Just to give you a little bit of perspective, bank accounts are probably going to be earning less than about 4%. So if you end up with something a lot bigger than that, you probably made a mistake. For example, if I had come up with 25%, that would not have been reasonable for a bank account. Okay, next one, you earn 2% interest in a bank account. You deposit 800, and this time we're trying to find the length of time to earn $100 in interest. So just like always, start with your equation. I equals principal times rate times time. It tells us our interest rate is 2%. So when I substitute that as a decimal, 2% would be 2/100ths. I deposit $800, so that's my principal. And the amount of interest is $100, so that will go in place of interest. Okay, we'll bring down everything we haven't used yet. So we have an equal sign, some multiplication signs, and T to represent time. Again, it says how long does it take, so it would make sense that we're solving for T. All right, I'm going to go ahead and multiply 800 by 2/100ths. So that's going to come out to 16. I can place that back in my equation. And then to get T by itself, we will divide by 16 on each side. And then we can set up division. 100 divided by 16. So I know that 15 can go into 90, so I'm going to take a guess that 16 can go into 100 6 times. And 6 times 16 is 96. So I will add my decimal point, and 16 can go into 40 twice to get to 32. And 16 will go into 80 exactly 5 times. So my time is 6.25. And since time is always represented in years, I will put years on it. So basically 25 hundredths of a year, that would be 1/4 of a year, or 3 months. So just so it makes a little bit more sense, this would be equal to 6 years and 3 months. perfectly fine to leave your amount of time as a decimal, but just so you understand what that number means. All right, moving on to our final problem for your notes. You borrow $600. The interest rate is 15%, and it takes you 5 years to pay off the loan. So we'll start with interest equals principal times rate times time. And we'll go ahead and substitute all of our values in. You borrow $600, so that amount is your principal. The interest rate is 15%, which would be 15/100ths as a decimal. And the amount of time is 5 years. So we can go ahead, bring down interest equals 600 times 15/100ths multiplied by 5. Okay, everything's on the same side of the equation here, so I can go ahead and start multiplying. Kind of like before, I'm going to do 600 times 5 first, just because it's a little easier to do the whole numbers first. That's going to give me 3,000, and then I can multiply 3,000 by 15%. And when you work out each of those rows, you're going to end up with this value. My decimal is moved over 2 digits in 15%, so I'm going to move it over 2 digits to 450. So interest equals $450. So think about that for a second. You bought something that only cost $600, yet you have to pay an additional $450 in interest. So that might seem like a lot, but that is something that happens all the time when you're buying things and taking out a loan for them. So just be aware of that as you become a consumer. If we look at our total value, your original amount that you borrowed was $600. You're paying an additional $450 in interest. So altogether, your violin is going to end up costing $1,050 when it was only worth $600. So just something to consider as you start making financial decisions. All right, that concludes interest video notes. Again, be sure that you are always, always, always starting with the equation, then plugging in the values you know before you start solving. Thank you for watching.